So hi everyone. I guess everyone are a bit tired, including myself. So my name is Matan. I'm from the DAOStack project, but I will focus today my talk on the holographic consensus and scalable DAOs. So basically, what I think is the most promising avenue of blockchain, that is DAOs, and what I think is the most prominent problem of DAOs, which is how to scale their governance. And what I think is a possible solution for that problem, which is holographic consensus. So this will be the focus of my talk. OK, so let's start slowly with what do we mean by DAOs and what do we mean by blockchain governance. So these will be my 3 requirements for what I would expect from a DAO to satisfy. So obviously, firstly, it should be decentralized, right? So by decentralization, we mean there is a wide and open distribution of influence. So it's not like a closed, small set of voters or influencers or deciders. And then there are 2 critical criteria. So firstly, it has to be resistance. It has to be resilient or resistance against manipulations, right? Because otherwise, there is no real governance system. This is reflecting the influencers. And secondly, it has to be scalable. So if it's not scalable, if it's a small organization, why to bother from the beginning? Like, why to have it decentralized? So the whole power of decentralized organization is that it can grow and ideally grow indefinitely. And I add here in parentheses, I add super growing or super effectively, growing super effectively, which means that in contrary to current organizations, when they grow up, their effectivity goes down, the effectivity per person. So indefinitely scalable organization can grow up forever, but super scalable organization become more effective as they grow up per person. And we are familiar with those kind of structures. We call them network effects, we call them the internet itself, and so on and so forth. So can we construct an organization that behaves like a network effect such that it becomes more and more effective per person as it's scaled up? So that would be the ideal scenario. OK, so what do we mean by blockchain governance? So blockchain governance is a sort of like a function. So given a proposal, given an idea that we need to decide about, it takes in the inputs of agents. So there are n agents in the system, and influencing agents in the system. It takes in those inputs and transform them into an outcome, into an output. Okay, and that's true for each and every proposal. So that would be the definition for blockchain governance. And that's how it looks in terms of implementation. Actual smart contract implementation, we call this the ARC governance framework in DAOStack. But going very briefly on that architecture, given an input in terms of proposals and then an input in terms of the opinions on those proposals, then there is the logics that trigger actions. So we call them governance schemes. Each governance scheme is a bit of logic that says if such and such happens, then the organization does such and such. Then these are the do's. Then there's other kind of bit of logic of governance. We call them the global constraints, which basically says no matter what happens, the organization will not do such and such. So then there's the inputs of the agents. The inputs trigger the governance schemes. The governance scheme trigger the controller. The controller verifies with the global constraints that everything is OK. And if there's action triggered, it triggers the actors. So there are 2 internal actors, the token contract of that specific agency and the reputation contract of that specific agency. I will say a few things about reputation. And then there is also the avatar contract, which is basically the face of that organization. The avatar is a contract that can do anything else in the blockchain. So outcomes will look like printing tokens of that agency, distributing reputation of that agency, or basically doing anything else inside the blockchain. OK, so this is just like a kind of like a side remark that the decentralized governance is a consensus protocol between subjective agents with their subjective inputs, reaching agreement about subjective realities. So it's kind of like generalization of what we know of consensus protocols like the blockchain itself. But the difference is that the inputs that are coming from agents that trigger decisions are subjective inputs, are not inputs that can be evaluated by a machine, by a program. And that's why we need human agents to evaluate those inputs. So what kind of outputs, what kind of decisions or realities do we want to agree about? So for example, allocation of resources, such as tokens, to agents in the system to incentivize actions. Maybe metadata, so we want to decide about curation of objects. And then finally, we would like to decide about the governance system itself, such as the protocol and perhaps the reputation distribution. So maybe a side remark about reputation, because I know it's kind of like a charged issue or charged matter in the community. So firstly, let me just say what do I mean by reputation, because there's a lot of different people are speaking about reputation in different contexts, so just setting up the language that I'm using. So reputation is a numerical attribution given to each agent. It's a non-transferable attribution, so it's not a token. And if you see, there is an asterisk over here to say that you might be able actually to transfer reputation, or you might like to have the transferability of reputation in a DAO, but not an ordinary transferability of a token. So maybe transferability under some restricted conditions. And then finally, that's the important line, it simply amounts to influence or voting power in the governance system. So in every governance system, you have agents that are expressing opinions, and then you are collecting the sum of those inputs, and you are making them into a decision, and then you need to weigh different inputs differently. So you have, of course, token-based voting, which weigh by tokens or by tokens staked. And then if you have a reputation system, you are weighing the inputs of agents by that number. And then a lot of people are asking, OK, but how reputation flows in the system? How reputation changes in the system? So reputation flow amounts to either awarding of reputation for contribution of value. So let's say I'm proposing a proposal, and that proposal is eventually becomes successful, so I will be awarded with reputation for making that successful proposal. Or maybe I will submit code to the development community, and again, I will get reputation. And the awarding of that reputation is part of the protocol itself, so it's part of the decision-making itself. And then second kind of reputation flow is that if I'm voting with my reputation, so as far as I'm in alignment with the DAO, my reputation increases. When I'm in misalignment with the DAO, my reputation decreases. And this is this is a side argument. I'm not going to dwell into that, but I think it's important. So the argument is that being non-tradable, reputation-based voting systems are much more resilient to manipulation than token-based voting systems. So I will stick to reputation from now on, and I will not explain that any further. So let's now ask, what is the biggest problem of DAOs that we have, or why don't we see DAOs already? So let's go back to the two requirements from a decentralized organization. We want to have it scalable, and we want to have it resilient. But let's define those terms in a bit more detail. So firstly, scalability is simply the ability to scale up decision-making capacity by scaling up the number of participating agents, and more so the number of effective decisions that the DAO can make in a unit of time. So let's say that in an average DAO, one person will make a proposal once a month. So if you have a DAO of 100 people, it means that you have a stack of 100 proposals in a month to decide about. OK, that makes sense. That's probably, we don't need much technology for that. But what about a DAO of 10,000 people? That DAO will have 10,000 proposals in the stack that needs to decide about. So the scalability of the DAO is the ability to process that 10,000 decisions in that month. And then protocol resilience. So let me make an intermediary, middle step definition. So let's define the global opinion or the truth of that DAO. So the global opinion for the DAO is the decision that the DAO would have made if it would have a complete input set. So by complete input set, I mean if all agents in the system have the sufficient capacity and sufficient attention to look and consider each and every decision and make their opinion. Okay? Even if that opinion is, I don't have an opinion, that is sufficient too. So assuming we have a complete input set, assuming we have sufficient capacity, sufficient attention in the system, then the decisions that DAO will make, we'll call them the global opinions. Now we'll define resiliency to be that decisions are in the system are made in line with the global opinion. But now we are hitting a direct head-on collision, a direct tension, or a principal tension, which is that if we require from the system to have too much attention on each and every decision, so global decision, if we actually require each and every agent to look at each and every decision, then clearly it makes the governance system not scalable, right? If we have 10,000 agents and 10,000 decisions to make in a month, clearly we cannot expect all of them look at each and every decision. But then if we have too little attention on each decision, so we call them local decisions, so maybe we are allowing for decision to be made by small amount of reputation or small amount of people, that really makes the governance system not resilient, because those people are not anymore representative or reflecting the global opinion of the DAO. And in particular, can also manipulate the decisions. So there is a strong tension between scalability and resilience. And in fact, any consensus system, including blockchain itself, has the same principal tension between scalability and resilience. OK, so a decentralized, resilient, and scalable governance system, that's like the only, by definition, that's the solution. A decentralized, resilient, and scalable governance system has to allow for local decisions, right, for sake of scalability, that are guaranteed to be in line with the global opinion. So you need to have some sort of magic. You need to allow somehow for local decisions, for scalability, but those decisions have to be in line with the global opinion for sake of resilience. And that's exactly what we'll define to be holographic consensus. So holographic consensus is a decentralized governance system that allows for local decisions that are guaranteed to be in line with the global opinion. So for the rest of my talk, I will try to sketch how holographic consensus looks like, both in principle and in some details. OK, so firstly, in summary, so holographic consensus, as I said, allows for local decisions that are guaranteed to be in line with the DAO's global opinion. Let me define a little bit further what I mean by local decisions. So local decisions are decisions that are made with relative majority. So absolute majority is that we are asking all of the reputation holders in the system what they think, and then the majority of all reputation holders say yes. Then that's an absolute majority. A relative majority is, for example, when I ask a question, and then I wait for 1 week, I see who votes in that 1 week, and I only consider the majority of those voters. So it's a relative majority rather than the absolute majority of all reputation holders. So that's, of course, a very scalable approach, but by itself is very unresilient or non-resilient. Secondly, how do we achieve that alignment? How do we achieve that alignment between local decisions? We just probe a slice of the system, right? Just a slice that has the capacity of attention to react to our question. How do we make that process, that local decision process, to be guaranteed in alignment with the global decision? So the answer is that we are creating a crypto-economic gain. So alignment is acquired by crypto-economically incentivizing the discovery of and the protection from misalignment. And I'll show you how it works. This, by the way, if you're familiar with off-chain computation protocols such as TrueBit or the precursor of Ethereum computation market, this is just the subjective analog of that objective. That's the objective limit of that protocol. Why we call it holographic? Well, it's kind of like analogous to the hologram. In a hologram, you can look at any slice of the picture, and you actually have the information for the entire three-dimensional image. So in that sense, it's kind of like analogous in the sense that you can probe a slice of the system, of the governance system, and still get a faithful answer that reflects the entire system. OK, so let me quickly go with a prescription, and then we'll dive into more details. So firstly, we start with default proposals. So anyone can come up with any proposal. And by default, those proposals, in order to be executed, need to be approved by an absolute majority. So that's, of course, by definition, in line with the global opinion. Then, as said before, we have to have an extra stage, like an extra phase. We have to allow for boosted proposals. We call them boosted proposals. And those boosted proposals are open for a finite time, let's say a week. And after that time, they are decided by relative majority. So we have to have that stage, or that phase. However, we need to protect that phase. We need to protect which decisions can be boosted and how. So the way it works is that predictors, there is a predictor network, and those predictors place predictions about the outcome of proposals. And the way that they place those predictions is by placing a stake, basically staking Gen tokens. They place a stake about the predictions of, or about the outcome of proposals. Then second step, proposals are boosted only upon sufficient positive signal. So there are two kinds of signals in the system, and we'll get into it later. There are two kinds of signals. The first signal is that predictors are looking at an ocean of proposals. So there are like 10,000 proposals in the queue, and then they are looking at the ocean of those proposals and flagging or signaling for those proposals which are interesting, and they are willing to place a bet on that, a stake on that. So I'm looking at 10,000 proposals, maybe I'm looking at 100 of them, and I see one proposal that I think fits perfectly that DAO. I'm willing to stake 1,000 Gen tokens that this proposal is going to pass in that DAO, in any of those DAOs. There is a second kind of signaling, which is the opposite. So once there is a sufficient positive signal, so once there is sufficient stake of predictors that is predicting that a certain proposal is going to pass, then there is the opposite signal, and maybe I think that this is overhyped or over-promoted, and I'm willing to stake against that. I'm willing to stake 1,000 Gen tokens that this proposal will not pass. Only if there is sufficient positive signal for a proposal, only then it can be boosted. So in that sense, the voting system outsources the navigation of the collective attention to an economically driven predictors network. And by that, it can be indefinitely scaled up. There is a cost, there is economic cost to scaling up, but given that economic cost, you can show that you can indefinitely scale up. Well, given the economic cost and given that you have a network effect of predictors, you can show that you can indefinitely scale up decision-making capacity in a resilient manner. And note that decisions are still made only by reputation holders. So this is different from Feudarchy. In Feudarchy, you have predictions, and then you have also decisions, but the predictions and decisions are made by the same network. In here, you're separating the signal made by predictors and the decision, which is made by the reputation holders. And I would argue that that's much more stable and resilient strategy. So let's go a bit more details. So that's how it looks like in a diagram. So you have a queue of proposal over here. This queue operates with an absolute majority. So voters can vote with their reputation on each and every proposal. And if a proposal reaches an absolute majority of yes, it's being executed. Now there is incoming flow of proposal. Anyone can bring in a new proposal. Maybe there's some proposal fee that needs to be paid. And then predictors, there's a second action. Predictors can stake Gen tokens about the outcome of those proposals, and there is an order to that. So firstly, there's the fishermen, that they are predicting that a certain proposal out of an ocean of proposal is interesting and will pass. And after there is a sufficient positive signal, only then there is the challengers who then willing to stake tokens that those positive signals are actually fake. And then only if there is a sufficient positive signal, and I will get back to it in a minute, only then the proposal can be boosted, which means that it goes to another queue, and this is the boosting queue. In that queue, proposals are being opened to a finite time, a shorter time, maybe a week, maybe 3 days, depending on the DAO. In that queue, proposals are being executed or decided about with relative majority. So if majority of voters who vote in that time period say yes, it's being executed. If they say no, it's being rejected. And finally, there is also quiet ending period that, if you are familiar with finite time attacks, is critical. And still, I'm emphasizing again because it's a question that I keep getting, that the decision is only made by the voters and not by the predictors. Finally, really, like two important things. One is that there is a predictor bounty that I haven't told you about, but basically there is an economic incentive put here by the DAO or by the fees from the incoming proposals, either depending on the use case, but that bounty is critical. That bounty makes the incentivization for the positive predictors to find out those interesting proposals. Once there is a positive signal, that the stake from the positive signal becomes the bounty for the negative, the challengers, okay? But in order to start that process, you have to have that positive bounty. So that's, and you can think of it as the cost of management, the cost of scaling up your management or decision-making capacity. The second important point is that, you see, I told you that there is a certain boosting threshold, the sufficient positive signal, which basically means the sufficient stake is staked on predicting that a certain proposal is going to pass. But now I'm also adding that this threshold is actually dynamic, and it's exponential in the number of proposals that are already open, already boosted. So the more proposals are already boosted, the more, and in fact non-linearly more, collective attention is already diluted, and thus you need to have a higher threshold for boosting yet another proposal, and that's important. Okay, almost towards the end. Let me try to argue quickly, without getting into rigorous details, let me try to argue that we achieved alignment of the local decisions with the global opinion. So let's assume that the proposal is not in line with the DAO global opinion. So now there are two options. Either it was not boosted or it was boosted. So if it was not boosted, right, then it's in the queue. If it's in the queue, it can only be approved by an absolute majority. Absolute majority is by definition the global opinion, right? So by definition, it's in line with the global opinion or not approved. On the other hand, if it has been boosted, it means that there is an economic incentive to put a stake. If it has been boosted, it's only because there was a sufficient stake put on the proposal predicting it's going to pass. But that then stake becomes the bounty for the challenger, so that there's an economic incentive to put a stake in a test that this proposal is not in line with the global opinion. So if you think that it's wrong, you have an economic incentive to say that, to express that, and signal that on the network. And more so, once you did that, you also you have a skin in the game, and you have the economic incentive to then to call the right voters you think are missing from that vote process that will change the result. And notice that the boosting threshold, as I mentioned before, and thus the economic incentive to stake against the boosted proposal is exponential in the number of already boosted proposals, which then amounts to the dilution of collective attention, or if you wish, the extent that the global opinion is approximated. Why is it approximated? You see, here you have a finite number of proposals. So let's say there are 5 proposals open for 1 month. You would clearly agree that the entire collective attention is focused just about 5 proposals, and thus there is a global opinion. Even if people have not voted, it's not because they lack attention, right? But then what's approximating that fact? The size of that boost. Because if that boost is now 20 in a week, if that boost is now 100 in a week, is that still true that everyone have the capacity to vote on each and every decision? The answer is no. The answer is that it's continuous, and the larger that stack is, the more and more approximated is the fact that we are operating under a global opinion. But on the other hand, as shown here, the more proposal you have in the stack, the more the dilution of the collective attention, and thus the more the extent that the global opinion is approximated. But in order to protect that, there is exponential more incentive for predictors to signal for that situation. So finally, predictors have 3 roles. They signal for interesting proposal out of an ocean, they warn from bad promoted proposals, and finally, once staked and have skin in the game, they call for voters to reflect the global opinion. And to summarize the talk, there is a principal tension between scalability and resilience of DAOs. Holographic consensus is a suggested solution that makes local or relative majority decisions to be guaranteed in line with the global opinion. Predictors are incentivized. In order to achieve that, predictors are incentivized to find good, unnoticed proposals and to warn from bad, overly promoted ones. Boosted or relative majority decisions are only possible with a sufficient predictor stake. The positive stake, and thus the warning incentive, correlates with the extent that the collective attention is already diluted. And that makes decided proposals are guaranteed to be in line with global opinion, and the resilience scale tension is resolved or translated into economic cost. And the outcome is indefinitely a scalable organization. So let me end the talk with that. Thank you.